now we will move on to chapter 8. For this chapter, we'll be discussing 4 main topics, which is rounding whole numbers, rounding decimals, rounding significant figures, and finally, upper and lower bounds. Let's start with rounding whole number. This is a pretty simple concept. You can round whole numbers to the nearest multiple of 10, 100, 1,000, and so on. For example, there are 23,489 runners in a marathon. If you round that number to the nearest 10, you would get 23,490. Rounding it to the nearest 100, you will get 23,500. And rounding to the nearest 1,000, it will be 23,000, and so on. You get the point. If you want to round a number to the nearest 10, you round up if the number ends in 5, 6, 7, 8, or 9. For example, 25, 26, 27, 28, and 29 are all rounded up to 30. But if your number ends in 1, 2, 3, or 4, you will round down, so 21, 22, 23, 24 to the nearest 10 are rounded to 20. Next is rounding decimals. The digits to the right of the decimal point are called decimal places, or DP for short. The first decimal place is called the tenth, the second is called the hundredth, and so on. Here's an example. The square root of 3 would equal to 1.73205008 etc. And if we round that to the nearest whole number, we would get 2. When we round it to the nearest tenth, it will be 1.7. Rounding to 2 decimal places would be 1.73. Now rounding decimals is pretty similar to rounding whole numbers. First, you need to count the decimal places from the decimal point and look at the first digit to be removed. If you are rounding to 1 decimal place, from the second decimal place onward will be removed. If the value of the first digit to be removed is less than 5, just remove the unwanted place. But if the value of that digit is larger than 5, add 1 onto the last decimal place, then remove the unwanted one. For our first example, we will be rounding 23.88356 to 2 decimal places. Step number 1. Count 3 digits from the decimal point. Since 3 is less than 5, keep your last decimal, which is number 8, the same. Then remove the unwanted decimal places, which are 3, 5, and 6. For our next example, we will be rounding 2.30765 to 3 decimal places. Just like the previous example, count 4 digits from the decimal point. Number 6 will be the first digit you want to remove. But 6 is larger than 5, so you will need to add 1 to your last decimal place, which is adding 1 to 7. Then remove the unwanted decimal places. Let's move on to dealing with significant figures. We often use rounding to significant figures when we want to approximate a number with a lot of digits in it, such as population or the area of a country. Now, if you put the square root of 800 into your calculator, the result will be 28.28427125 etc. So, if we were to round that result to 4 significant figures, we would get 28.28. And when rounding to 3 significant figures, it would give us 28.3. Rounding to 2 significant figures would give us 28. And lastly, rounding to 1 significant figure would equal to 30. So how exactly do we round to significant figures? First, count the digits from the left. If you are rounding to 2 significant figures, count 2 digits. However, when the number is less than 1, you will need to count from the first non-zero digit. Then look at the next digit to the right. If it's less than 5, then leave the digit you counted the same. But if it's greater than or equal to 5, then you add 1 to the digit you counted. You can ignore all the other digits, but make sure to put in enough zeros to keep the number the right size. Here is the table of rounding to significant figures. You can pause the video now to take a closer look at it. Let's move on. If you still can't understand how to round to significant figures, then we'll guide you through it with our examples. Here we have 30,578, and we are going to round it to 3 significant figures. The first thing you should do is count 3 digits from the left. You then should have 5 as your counter digit. Look at the digit next to the right of your counter digit. It's 7. Since 7 is greater than 5, you need to add 1 to 5, and you'll get 30,600. For the second example, we'll be rounding 0.0658 to 2 significant figures. Start to count 2 digits at the first non-zero digit from the left, so you will start to count at 6. 5 will be your counter digit. Look at the digit next to 5, it's 8, and because 8 is greater than 5, you need to add 1 to your counter digit. Your answer should be 0.066. Now, how many significant figures should you round to would be suitable? For rough estimations, rounding to 1 significant figure would be acceptable. Rounding to 2 significant figures would give you a more reasonable approximation. This is usually enough for most quantities where you don't have to be exact. Rounding to 3 significant figures would allow for a more accurate approximation. This is usually the most precise you will need to be when it comes to everyday calculation. As you may know, every measurement has an upper and lower bound. This is also known as the limits of accuracy. For example, a journey of d kilometers that is measured as 26 kilometers to the nearest kilometer could be anything between 25.5 km and 26.5 km. 25.5 would round up to 26, while 26.5 would round up to 27, but anything less would round down to 26. So the limits of accuracy for d would be d is greater than or equal to 25.5 and smaller than 26.5 kilometers. To show you how to find the limits of accuracy for a measurement, we'll go through 2 examples. The first example is to find the upper and lower bound of 17 kilograms. The smallest number that could round to 17 would be 16.5, and the smallest number that could round to 18 is 17.5, so anything less than 17.5 could be rounded to 17. This means your limits of accuracy will be mass in kilogram greater than or equal to 16.5 and smaller than 17.5 kilograms. Our second example is to find the upper and lower bound of 75 cm rounded to the nearest 5 cm. Rounded to the nearest 5 cm means the difference between the upper and lower bound is 5 cm. So you'll need to calculate the upper and lower bound. The lower bound is calculated by subtracting 75 to 5/2, and the upper bound is calculated by adding 75 to 5/2. Thus, you will get length in centimeter greater than or equal to 72.5 and smaller than 77.5 centimeter as the limits of accuracy. Sometimes you will need to calculate the lower and upper bounds of a measurement using the given quantities. So here's how to do it. Our question is, a car travels 125 km, which is rounded to the nearest kilometer and uses 16.1 liters of fuel, which is corrected to 1 decimal place. Find the upper and lower bounds of the fuel consumption in kilometer per liter. The first step for all questions like this is to find the upper and lower bounds of all your given quantities. We know 125 kilometers is the rounded distance to the nearest kilometer, so its limits of accuracy will be distance in kilometer greater than or equal to 124.5 and less than 125.5. The limits of accuracy of fuel in liters will be fuel in liters greater than or equal to 16.05 and less than 16.15. Now you can find the upper and lower bounds of the fuel consumption. Since we are dividing to find the upper bound, you take the upper bound of the distance, which is the numerator, and the lower bound of the fuel used, the denominator. Then calculate the lower bound similar to the upper bound, but divide the lower bound of distance by the upper bound of the fuel used. Your answer now should be fuel consumption in kilometer per liter greater than or equal to 7.709 and less than 7.819 when answers are rounded to 3 decimal places. And that's it. I hope you all enjoyed the video and thank you so much for listening to our presentation.